Hey there and welcome back to the Code Wrinkles channel for this brand new video in which I want to start right from the beginning with a question to you directly. So how performant do you think that your strings are? Or to be more specific, how performant is the way that you actually use to create strings? Because when it comes to working with strings in real applications, production-ready applications, we actually almost never work with string literals because we usually have to compose a certain string based on different information that we might have in different other variables. So when it comes to that, we actually have two major ways that are actually probably the most popular ones that you might use in order to create your strings. So the first approach that we'll also see here in the screen would be to use the string interpolation. And string interpolation, it's actually very, very simple. It's this idea of having this dollar sign at the beginning, and then we simply can use the curly braces and put then the variables that we need to be actually represented as a string right at that specific point. Now, another option would be to use the string format method, which also we can use or think about as a templated strings or strings with params, and it actually works like this. You just provide here a string with like a placeholder value, and then you have to provide the value that you would actually like to replace in the template. Now, when it comes to how these two different methods work, there are different opinions out there, and what I would like to actually do here in this video is actually look what happens really when we run this type of code, how these two methods work, and of course which one of them is the more performant one, if there is a more performant one. And probably if you're watching, you're already saying, hey, but you forgot to mention the string builder here. And no, I didn't forget to mention the string builder, and we'll come to the string builder just a little bit later. But for now, I just want to get started from these two examples, because starting from here, we can have actually a very nice discussion, and we can already see, or we will be able to see a lot of interesting things that might actually make us think differently about string performance and especially about string interpolation. Now, what I have already done to set this up is I have created here a benchmark class, and of course I have added benchmark.net as a NuGet package here, and in my program.cs class I just want to use a benchmark runner and to perform this type of tests. Now, as you might see here from the string operations, what we do is actually the same. The only thing is that we do it in different ways. So let's change here this to be release, and let's run the application, and just we should let benchmark.net perform its job. As we already play with very, very few strings, like 5, that should actually not take very, very long. Of course, as a regular process from benchmark.net, it actually then tries to clean up all the things that are not needed. It then tries to perform some warm-up runs, and then it will actually perform the actual work. And of course, before everything gets started, a build is done, of course, using the release configuration, so that benchmark.net can actually run this directly in this release configuration, because otherwise it simply wouldn't work, and it wouldn't make sense to actually run a benchmark on that. And it should be ready just in a few seconds, I guess. So just hold on one little bit more, and we'll be able to see some results, with which I guess that could be a little bit like of a teaser. They might be a little bit surprising to you, as if they were for me, because I have to tell you here a kind of like a fun story, because I initially planned to do this video on a slightly different topic, still regarding strings and performance, but on something else. And then I stumbled across this type of thing that's actually, and you will see, very new in C#10 and in the newest version of the Roslyn compiler. And that might actually think the way or change the way that you think about string interpolation. So let's just look into the results right now. So we see that we have this string params method, and we have this string interpolation method. And well, it seems that the string interpolation method right now runs faster than this string params method. And it also allocates less memory, which is very, very interesting to know, because based on my understanding or on my knowledge about how strings are actually handled under the hood and what happens in this case. I would actually have expected these two methods to actually return very similar results. So I clearly didn't expect, for instance, that the string interpolation in this case, first of all, will be much faster than using templated strings, and second of all, that it would actually allocate less memory here. So the reason why I say that I wouldn't really directly expect that is because let's just copy this code and go, for instance, to a website where we can actually see how our code gets lowered. Because right before the code gets actually compiled, it gets lowered. It actually lowering means that all syntactic sugar is stripped away from your code, and it's just bare C# code, which is I would say closest to what actually the compiler needs to perform its work. So if we put these two methods that we have here in this sharplab.io site, what we can actually see is that those two methods get lowered to actually the exact same thing. And you see that the for loop is actually replaced with a while loop. We have this this counter here, which is the num, and we actually do the stuff here, and it's exactly the same thing. So under the hood, we can see here that both of these methods, when they get lowered, or also string interpolation, when it gets lowered, it actually it's actually lowered to also a string format and to a templated string. And therefore, I would have expected, as said, that my methods here would perform actually the same. But there's one very, very important thing to note here, and actually we can close this for now. So I will take advantage of some tools that actually ReSharper has. ReSharper, but in my case using JetBrains Rider. So if we can go here and on tools, we can switch on the IL viewer, so the intermediate language viewer. So what I did then is, okay, I said let's take a look at how these two methods get compiled to intermediate language. So let's just click on the first one, so we see where this actually happens. And here we see that, okay, some things happen here. We have this init function, and we see that we have actually two params that are passed in it. First, an I, that would be the integer, of course. And then we see here something very strange, like a system runtime compile services and default interpolated string builder. And we'll come back to that. And if we look a little bit what happens here in this loop is actually, we'll see that we have a lot of calls to, well, different parts of our compiler services. And actually all of these are value types. So all of these are living on the stack while these methods get executed. And we see that also the string itself from which we are starting is actually like this. So there seems to be kind of like a placeholder that will in some way actually put the value there once this code gets executed. Now, if we go and take a look at this other method of the string format, we see that it's actually much more simpler than the first one. It only has here in this initialization function just one parameter that comes in, which is our I. And then, well, we see that actually the string itself is in this format. So we still have this placeholder here. And what it happens also, we see that we go here through a box process. So it means that our int, so our I, actually will get boxed to an object, because it is actually a value type, and it gets through this boxing process, through which it becomes a reference type. And then we have this string format method that gets executed, and then everything else is pretty straightforward. So if we analyze this, we see that even though in SharpLab we were able actually to see that both of these methods get lowered to the exact same code, when we look into the intermediate language here in Rider, we see that there are a major difference here. And the major difference is that here in this method that's actually executing, or that's creating the templated string, what happens is that we also have a boxing process, while in this other method we do not have any boxing process. And that would explain why actually our code, or our string interpolation method, performs better right now. However, let me even go back to the SharpLab thing, because here we can see that there's clearly a difference what we see in Rider and what we see here on sharplab.io. So if we go here and we say, I want to see also the intermediate language for that, and we see that also when it comes to the intermediate language, well, we have, first of all, this method with string params, which once again has this boxing process, like we also have seen previously. But we then also have here the same boxing process for this other method, you see. So it seems actually that what I get as intermediate language here in Rider is different than what I get as intermediate language here in SharpLab. So then the next thing to do here, and to actually explain what really happens and then try to actually gain some conclusion, let's maybe choose a specific Roslyn compiler branch that we actually want to use, and I'll use the main branch here. And if we check this, so if we use the main branch, we see that right now, actually, if we see the intermediate language here, it's exactly what we have in Rider. So the thing is that here in SharpLab, and this might be misleading if you're trying to actually look into how different things work using SharpLab. So the default that is using, it seems not to be the latest C# 10 Roslyn compiler, because even if we now change to C# to just see check out exactly to what code our two methods get lowered, we see that it's actually totally different. And that's actually the new way of working with interpolated strings in C# 10 that is really overpowered and is really fast. So if you heard previously people saying don't use string interpolation because it's not fast enough, then, well, that totally changed. Because what happens is right now, the string interpolation, while constructing the final string, actually it doesn't do any memory allocation at all. Everything here happens on the stack, because we have this here default interpolated string handler that is responsible for appending a literal, and then it is responsible for appending this formatted number, and then to create the string itself. However, the cool thing, or the nice thing to note here about this default interpolated string handler, is that while it is actually performing these operations, it is using read-only spans of chars and span of chars, which actually means that everything in this process of constructing this string happens still on the stack. So we don't really have a boxing process, because nothing is sent to the heap. Nothing is actually allocated in the memory. Everything works here using the power of spans and read-only spans in order to perform this type of work. While, of course, in the string format method that we have here, we see that it actually behaves like it did also behave before C# 10. So that's actually a major change that we have in C# 10 when it comes to working with interpolated strings. And that also explains, once again, the reason why actually this is faster than the string format. And as said, I would have expected initially that it would actually behave the same, which is not the case. So let's go maybe one step further and let's think about the StringBuilder, because well, you were talking about the StringBuilder, or probably you were using the StringBuilder a lot. Now, when it comes to the StringBuilder itself, the StringBuilder is actually very, very interesting, because theoretically it would be the preferred way to actually create strings, because it should be the most performant, as it previously it would not allocate anything except the StringBuilder itself. So then actually it might be more performant here. But let's add some code here. We have then StringBuilder with interpolation, because here we use this append method, and here we have this StringBuilder with a templated string. Now let's probably also go here to our benchmark project and maybe add here some benchmark for that. So public static void, or public void. It's not static here, so public void. Let's call this StringBuilder with interpolated string. And here we'll just call the string operations. Where is it? String operations. Okay. And let's have this string builder with interpolation. And let's also create a new method, public void string builder with template string. And here we'll have the string operations dot string builder with params, did we call. And of course, we just need to also add benchmark on top of them so that benchmark.net is able to actually see that it needs to perform some benchmark also on this method. So right now we should be good to go, so we can run this again and take a look at the results. And yeah, this will take just a few seconds until it completes, so we will be just right back when the operation finishes. Okay, so we have right now a completed benchmark. Let's make this a little bit bigger and let's take a look here. So we have the string params, which we see that it performs in, well, around 5 to 8 nanoseconds, and it allocates this amount of memory. Then we have the string interpolation that actually has a runtime or an execution time of around 364 nanoseconds. And it also allocates some memory. Then we have this string builder with interpolated string. And this one we'll see that's actually very, very close to the regular string params. And it's very close to the string interpolation part. But the only thing is, of course, and that's why, or that's because we are mostly using the string builder, probably the allocation is here way bigger. But if we use the string builder with templated string, then, well, that performs very, very, very slow. So there's another key takeaway that we could have from here is that if you're using the string builder, and once again, this is actually concerning, or this applies, this is true to C#10 and using the latest Roslyn compiler that comes with that. So it means that using the string builder, if you use it with templated strings, actually it's slower than even using only just regular string interpolation. Because once again, it's the string builder, we just have this object, and while it tries to actually format the string, it goes with all these templates through a boxing process. And that's why it's that slow, and that's also why the memory allocation is in this case way bigger than that. But you'll say probably, okay, but the power of the string builder was actually not residing in this way of actually just simply creating a very simple string with this append method. With the string builder, you could actually maybe create a string in different steps, and to make sure that the immutable string is only created at the end. So let's try to maybe replicate this scenario here in all of our methods. So I will move actually var my string here out of the loop, and I will set it to a string.empty. And of course, here, instead of doing this, we'll just concatenate the string using plus equal. That's how we would do it here. And the same thing is we will do also here. So first of all, here with templated params, var my string equals, and it would be string.empty. Okay, and here then my string, once again, it would be plus equal because we just want to concatenate them. And of course, it's not var my string, but it's just my string, and that should work. Here probably I have a typo, which is correct. So right now everything should be fine. And for the string builder, it's actually exactly the same. So what we do here in this case, well, we just append something, and in the end we just return the string, which is actually the way we did set up the method already. So I should have done this maybe a little bit differently, and within each iteration actually of this one, we would create a new string builder and create the string from it. But right now, yeah, basically, if we run the benchmarks once again, right now we would compare really apples to apples, because we would perform actually the exact same stuff here using templated string, here using a string builder with interpolated strings, and here using a string builder with templated strings. So all these four methods would have, if we just make them to return a string, and if we would use them in our code to actually get a string, then we would get exactly the same result. So all of these four methods would return the same result. However, let's run another benchmark on that. And right now, maybe our results that we will see would be a little bit more concludent. So let's wait just a few seconds until everything is done so we can have a look into that. So here we have the results. Let's just make this a little bit bigger and take a look at them. So once again, we have these four methods, and right now, as said, we are just comparing apples to apples because all these four methods are actually doing the exact same thing. So previously we were a little bit wrong because the first two methods were doing slightly different than the latter two methods that were using the string builder, and that would actually concatenate a bigger string containing all the strings added from each iteration through that loop. And it would then return one single string. So they were doing slightly different things, but now we have tweaked everything around a little bit, and right now all these four methods once again return the exact same thing. If you would like to use them in your code to get a string with each of these four methods, you would get, or you would yield exactly the same result. So if we take a look once again, this string with params, it have this 739 nanoseconds and it has an allocation of around 1096 bytes. This string interpolation, it runs with 562 nanoseconds, and it also has an allocation of 976. Now the string builder with interpolated string still has a very, very good result, better than everything else. It just runs with 384 nanoseconds, and it just allocates only 768 bytes. And the string builder with templated string, well, that's actually maybe performing the worst. It has 171 nanoseconds of execution time, and it also allocates 1200 bytes. So what can we take away from that? So we can take away a few very important things. But first of all, these string params, or the templated strings, they are using that string format. They are using under the hood, we have a boxing process that occurs, and therefore everything that we do actually with templated strings or with string format will actually go through this kind of boxing process, which of course will add or will come with a certain performance loss. The string interpolation, of course, as we have seen in .NET 6 and with C#10 and with the latest version of the Roslyn compiler, it actually uses the default interpolated string handlers that perform all the actions that they need to perform directly on the stack using the power of read-only spans and spans of char. And that's why the string interpolation method runs faster than the templated string method. Now, when it comes to the string builders methods, and here the results I would say are very expected, because we are basically using the exact same two ways of creating a string that we used in the previous method, but we are also adding the overhead of working with a string builder. So the idea is to check whether this overhead of working with a string builder actually really pays off. And if it comes here to the string builder with the interpolated string, it actually, we see that it's faster than the interpolated string itself, because it runs in around 384 nanoseconds, and it allocates also 768, so less than the string interpolation method. So we could actually then come to the conclusion that, for instance, if you actually need the string builder to iterate through some loops or to build a string in different steps that are really not known from the beginning, then using the string builder with interpolated strings would actually be the fastest way to create your string. But if you'd use a templated string in your string builder, then you might even be better off by just using a regular string interpolation instead of a string builder. So What this means is that even if we are actually, or if a lot of people say, and as we see that's actually true, but starting with C#10 in only a few circumstances, so that the string builder is faster than anything else, well, that's not totally true, because if you use, for instance, a string builder, but in that string builder you use templated string to append to the string builder, well, then actually it will not be faster. You could even use a regular interpolated string and it will still be faster than the string builder with the templated string. So the thing is here that we would actually need to be careful, or we would need to actually reconsider string interpolation starting with C#10, because it seems to be really the fastest way to create strings when you also need to insert some values from other variables into those strings. Now, one other word about the string builder is that you see that you have this append method. So if you have your application that was compiled maybe with .NET 5, for instance, now this append method, it appends a string, but it's using this string interpolation. So in .NET 5, it will probably, or it will surely actually use the old way of doing that. So it will behave exactly like the string format method. So it will go through that boxing process. Now, it means that in that case, this version of the method and this version of the method would actually perform exactly the same way. And the idea here is, and that's maybe something very good to note, is that if you just recompile your application with the latest .NET 6 and the latest Roslyn compiler, actually you don't have to change anything. Because what happened is that they added a lot of string builder overloads, and if we hover our mouse on this one, you'll notice that right now actually this will take in an interpolated string handler argument. You see the interpolated string to append. So it means that if you actually want to just take advantage of this new very powerful way of working with strings and with interpolated strings in C#10, the only thing that you would have to do is take your older application and recompile that actually with the new Roslyn compiler, or with with the C#10 compiler, and it will automatically actually behave exactly the same way. So the output of the intermediate language would be similar to what we have seen for this version. And this of course goes also for the string concatenation methods. If we use just the operator like we do here, or if we use the string concat method, it would actually do exactly the same. And one other thing is that even if you have append overloads or overload for other string operations that previously were not working with this default string handlers, the idea is that if you just recompile that, the compiler would actually prioritize if it finds a method, an overload that it takes in this, for instance, like we have for this append, that it takes in an interpolated string handler, then it will prioritize that overload instead of the others that are maybe using just a regular string, like we would have, for instance, here. You see that here this append would just take in the value and use that. Okay. So let's just have or enumerate once again the key points that we have here regarding string performance when it comes to string creation and the different string creation strategies that we use. And we can summarize this in actually very few key points. So the first key point is interpolated strings are definitely very performant in C#10. And thing is that you should probably use interpolated strings wherever you can use interpolated strings. Now, as we have seen for very simple string creation scenarios where we just have to create a string in one go and then that would be it, string interpolation might then just be enough. If you will just use the string builder to just create one very simple string that you could create with just a string interpolation, well, that would actually be less performant than the string interpolation itself. However, if you have to create a string in an iterative process that actually goes through a bunch of iterations and adds something to the string builder each time, then using the string builder might or is actually the better way to do that. And of course, using the string builder with interpolated strings, not with templated strings, because as we have seen, actually, the worst performant method that we have was the string builder with the templated strings. And that's actually, from my point of view, a major change of what happens actually, or what happened when it came to actually working with interpolated string and string creation in C#10. And the very nice thing here is that if you have older applications and you might be concerned about the performance of your applications because of how you're handling string creation, maybe you create a lot of strings, then you can just recompile this application using the latest version of the Roslyn compiler, and it will, in most cases, automatically actually use the new ways of creating strings, and it will make your application way more performant just by simply recompiling it with a newer C# version, and that would be it. That being said, thank you very much for watching. I hope this video was informative and you learned something from that. If you did enjoy this content, please don't be shy and feel free to hit the thumbs up button. Subscribe, of course, if you didn't do that already. And also make sure to hit the notification bell when you subscribe to be notified whenever something new happens here on the Code Wrinkles channel, because we try to actually come to you with a lot of good stuff during the entire week. And of course, you can even then share this content and the entire channel maybe with your peers, your colleagues, your friends, maybe through social media, maybe on Discord or on Reddit, or wherever you might be, and wherever you think there might be people that would find this type of content useful for them. Don't be shy and just share them. They will thank you for that, I suppose. And once again, thank you very much for watching and for joining in. And until the next time, I wish you the very best.